try and present to you a project that we'd like to propose in collaboration as well with Humasol, which is a sort of similar organisation. So I'll first talk about who Equinox and Humasol are, so that you get an idea of what we're about, and then I'll go into the project that we're proposing. So, first off, for any of you that don't really know, Equinox is an organisation that's been around for about 4 to 5 years now and works a lot in this department. We're a completely student-led research and development organisation, basically looking into ways that we can electrify rural communities using sort of basic and low-cost technologies so that we can make it affordable for bottom-of-the-pyramid customers, basically. We're trying to make it an open-source solution and as easy for other companies or other people to pick up our designs and sort of scale it up to electrify more people around the world. And we currently operate in Rwanda in Tanzania. The other company that you probably know less about is Humasol, which are a Belgian organisation that just work in any sort of renewable energy projects. They look into solar, heating, powering schools and stuff like that using biofuel, solar energy, hydro, any sort of renewable projects. And they are very interested in connecting students such as yourselves to real-world engineering projects for the purpose of getting renewable technologies out there and electrifying sort of, again, poorer communities. And they're operating in many places around the world, including Uganda, Kenya, Peru maybe. So that's a bit about who we are, and the project that we are proposing for you is to build 2 pieces of hardware basically that is of quite a bit of interest to us to improve the systems that we currently have in Africa and South America. The first part, and I'll sort of explain a bit more why we want this in a minute, is to build a maximum power point tracking module, or several modules that we can use to individually take power from a group of solar panels. Maximum power point tracking is basically a control technique to optimize how much power you're taking out of a solar panel. Secondly, we want you to build a charge controller which will correctly charge a lead-acid storage battery, so you can't just stick 12 volts in a battery and hope it'll charge. You'll just kill the battery. So we want you to develop a way of making charging it the proper way, and again at sort of a low cost, and it should be competitively cost to off-the-shelf components. That's why we want you to build it. So the idea of the maximum power point tracking modules is this. If you focus on the top image, first off, this is how we and most conventional people will use solar panels. You group the panels together, put them through a single charge controller and maximum power point tracking controller, and then you get your output power. What we're proposing is we have individual modules per panel, and then you put them on a bus voltage line into the charge controller that we want you to develop, and again you get your output power. In this situation, you can see sort of the output power sort of is conceptualized to be the same, but as soon as you start shading panels, and it's a bit of a different story. What happens when you shade a group of panels, if one panel is uniformly shaded, then the power output of that will decrease, and it will pull down the power output of the other panels that it's grouped to, and you get less power than if you individually use an MPPT module on each panel. So we want you to design these modules that can connect into the charge controller, and also investigate what is the cost versus performance balance of it. So there's clearly more hardware in this case. It's all lower rated, so is it going to cost more or less for the amount of power that we're going to get out of the panels? So the challenges involved are what you're going to be doing is you're going to be doing, for those of you that the third year power electronics course is a bit more of that, but you'll a bit more different sort of styles of control. You've got power management, which is how to charge the battery, how to charge the storage battery correctly, and you want to introduce certain protections for that so that you don't short the battery accidentally, or so that it's robust for general operation in an African country or South America where the people operating it may not know what's going on. And it really is about sort of creating something functional at the end of this project that we want to see working, and it is for real world use. So we will hopefully be testing it in summer this summer. The project is important to us because we want to know what are the performance benefits. So we're not just giving it to you just to give you a project. We genuinely want to know what's happening and get something out of this. We want to know, can we improve our power output in our kiosks, for Equinox in particular, by having this modular system? And is it going to be cheaper for us to do that? in terms of the charge controller, we currently just buy them off the shelf, and that might cost between £100 to £200. We want to see, can you build one for us that will... There are obviously going to be some trade-offs if it's a lower cost, but there are only certain performance requirements that we need, so can you build one to the specification we give you and at lower cost? So we will need to investigate that. And in addition, the small maximum power point tracking modules will have other applications. So a product that Equinox already produces is what we call the Azuba box, and it's literally a personal electricity supply for a customer. And to connect it to a solar panel, or to optimize how much power they can charge their battery box with a solar panel, they want an MPPT module. So there are other applications for what these designs are for as well. What you gain from it is there's sort of a broad range of topics that you'll be covering. So you'll hopefully get a lot more experience with hardware and software integration and working with hardware softwares and stuff in Imperial. You won't have been exposed to a lot of it yet in Imperial. So this will be a really good opportunity to get some more experience with that. I think a pretty key thing is if you're really interested in the renewable technology industry, then you'll get a greater understanding of solar generation and solar power, and you'll have to learn a lot more about that to sort of really push the project. Equinox and Humasol members will be very supportive, so we have a broad range of knowledge as well that we'll try and help you with. We want you to really get into building these things yourself and do proper engineering, so we'll try and support you and push you forward on that so you can get into that quickly and provide you with what information we already know. And hopefully you'll see the products actually go, at least for Equinox, into Rwanda in 2013 or 14, where we can actually test them and see if we'll get some real world parameters over sort of a 6-month period or something like that. So the overview again of what we want you to do: design and build a set of maximum power point tracking modules, maybe 2 or 3. They just be the same design. Investigate, is it going to be cheaper for us to do it this way or stick with the traditional method of grouping solar panels? And then also design a competitively costing charge controller for charging a lead-acid storage battery. And we've got a set of specifications that we want you to meet as well in that design. So that's it, really. If you've got any other questions, you can generally find me in the Level 5 labs, or you can email me. And yeah, I look forward to